So this is the first day of literal equations. Literal equations are equations where there are few, if any, like numbers. They're basically, remember when we solved for, when we converted from slope intercept form into standard form? We have that on our notes here, like that's here, when we went from this form into this form. This is actually a literal equation where we're going, basically all we're doing is we're rearranging an equation. We're not like finding one number. We're not like, like we've been solving equations and we find one number answer or a range of numbers with inequalities. We're not doing that. That's not what we're doing. Now we're kind of rearranging, restructuring equations. I know that sounds crazy. So I'm going to start with an example that will hopefully help us understand how this works. Okay, so every morning, so I'm wearing shoes with sneakers because it's cold outside. I mean, it's Texas cold. All right. So I'm wearing sneakers. So what do I do before I put on my sneakers? Yeah, I put on my socks because, like, again, I need the extra warmth. But I put on my socks and then I put on my sneakers. When I get home, do I take my socks off first? No, because, like, how? Okay. So in the morning, again, you're watching. I'll tell you, I'll let you copy. In the morning, first I put, let me zoom in a little bit, I put on socks. And then, second, I put on my shoes, all right? And I do them in this order, right? At first I put on socks, then shoes. When I get home in the evening, okay, I had my shoes on, so then I take off my shoes, and then I take off my socks. So I put them on in this order. So I put them on in this order, I take them off in reverse order, right? I mean, like, I can't take my shoes off before I take my socks off. I take my socks off before I take my shoes off. You understand what I'm trying to say. Okay? Take a second and copy that down, and then we're going to move to the next step. All right. So what does this matter? Okay? So what this is actually how we solve an equation. I take an x, I do some stuff to it, I do some more stuff to it, and then it ends up with some number answer. If I want to solve that equation, I have to undo those things in reverse order. It's the same process. Now, we always, in all of your classes, all of your prior classes, we've pretty much given you a set of steps, right? We've given you a set of steps that you can use to solve these problems. Well, sorry about that, because these steps won't help you. Because the reason why we were able to give you steps is because most of the equations that we've given you up until now looked exactly the same. They all looked like y equals 3x plus 5. They were all 2x plus 5 equals 3x minus 7. Well, now they all look like this, okay? They look different. They don't look the same anymore. It's not like I can get the x's on one side and the y's on the other side, because there's no x's on numbers. There's no x's and there's no numbers, okay? So every time I approach one of these literal equations, I've got to make a new plan, okay? And that's what this is about. This is about us figuring out how to make a plan for each equation we're going to solve. So I'm going to show you how to do this with an equation that should be pretty familiar. It's something that you're used to seeing. And then I'm going to move on to some stuff that's a little bit different. Okay, so the first thing that we're going to do is we're going to we're going to do 2x plus 4 equals 12. Okay, that's the equation we're going to solve. I feel like I can make this clearer. Sorry, just a second. It's a little... Oh, there it is. Okay. All right. So we call this process do, undo. So what I do is I look at the variable I'm trying to solve for, the variable I'm trying to isolate. I make a list of everything I did to it. I list them in the order that I did them, and then I make a list in the opposite order of how I'm going to undo them. Okay? So I make a list of how I broke it, and then I make a list of how I'm going to fix it. Okay? So we start with our order of operations process. What acronym do y'all use for order of operations? Do y'all use PEMDAS, GEMMA, GEMS? What do y'all use? Or do you even remember?
I don't remember.
That's okay. Yeah, if you have to ask that question, you don't know what it is. So then I'm going to tell y'all the one that I use. Okay, the one that I use is GEMMA.
Drive, equation, multiplication, and addition.
It's close. It's grouping symbols. So grouping, exponents, multiplicative, additive. Okay? So this is the process I like because it's very algebra focused, and it really does help us kind of think through what's happening. Because those are the things we're going to see. We're going to see grouping. We might see exponents. We might see something with multiplicative. We might see something with additive. Now, let's review what's multiplicative and what's additive. Okay? So multiplicative, let me zoom in a little bit. So multiplicative, first of all, has too many I's in it. I'm just saying. Like I put like 12 I's last period. I just put dot and I's all over the place, okay? So multiplicative might look like that. It might look like that. It might look like that. Obviously, it might have different numbers, right? There might be like a negative somewhere, right? Okay, so like it's going to look like something like that, where we're just multiplying. Now, that does not mean that we're not going to combine those two things, but we're going to look for things that look multiplicative. Okay, the other one we might see is additive. Let's find another pen. Is this one even going to work? Let's find out. Then we might have additive. Okay, and additive is going to look like we're adding or subtracting something. So it might look like y equals x plus 3, or y equals x minus 7, something like that. Okay, let's take a second and write this stuff down. Okay, so now that we've got that written down and we kind of understand multiplicative and additive, let's talk about what this means. So what we're going to do is we're going to start with GEMMA. And we're going to make a list. So I'm going to write do. And you guys, I'll give you time to write this down. I want you to just focus on what I'm doing. So I don't want you writing. I want you looking at what I'm doing. Okay? So I'm going to look at the variable I'm trying to solve for. I'm going to write down everything I did. Okay, well, this pen's not going to work. Everything I did to it. All right? So I like to highlight the variable. As we start to do more complicated ones, so like ones with like a whole bunch of letters, like this, it's real important to pay attention to what variable you're working with. Because I'll tell you right now, when I keyed this, I actually lost track on 2 or 3 problems and had to do them again. Because I kind of lost track of which variable I was trying to isolate. So we want to make sure that we keep track of it. So you can circle it or you can highlight it. I like to highlight because I can go through and highlight at least at the beginning, highlight the variable so I know what I'm trying to get by itself. Okay? So I'm going to look at that variable I highlighted and I'm going to go through GEMMA and I'm going to see if I see any of these things. So G is grouping symbols. Do I see any grouping symbols? Nope. Good. Let's cross it off. Do I see any exponents? Pencils down. Do I see any exponents, meaning something raised to a power? Nope, go us, we cross it off. Now, do I see anything multiplicative? So anything that looks like one of these 3 things? Yeah, I see that 2x. So what does 2x mean? I multiplied the x by 2, right? So I multiplied by 2. So I'm literally just writing down what I did. So I had some number, I multiplied it by 2, added 4, and it turned out to be 12. I'm trying to figure out what that number is, so I'm working backwards, okay? So I multiplied it by 2. Is there anything else multiplicative happening? No. Okay, what about additive? Do I see adding anything? So what did I add? I added 4. Is there anything else? I haven't done anything else. I'm done. I've looked at everything. Okay, so this is what I did. So this is my do list. I went top down and did it. So now I'm going to write an undo list. Okay, so I start at the bottom. So if I added 4, how do I undo adding 4? I subtract 4. And how do I undo multiplying by 2? I divide by 2. Now, this is what you would have done anyway, but this is why you're doing it. You're doing it because we're undoing what we did to that variable. So now let's just go ahead and do it, okay? So I'm going to, and again, remember, I do the opposite in reverse order, right? So I'm going to subtract 4 first from both sides. This zeroes away, and I'm left with 2x equals 8. So I've done that step. Now I'm going to divide by 2. X equals 4. This is what we actually do when we solve an equation. We've just been giving you a bunch of steps, but this is why you're doing it. We need to do this in order to be able to solve literal equations. So why don't y'all take a minute, write this down, make sure that you've got it written down, and then we're going to try a couple. Okay, so this is not the exact problem that y'all just did, but if we look at it, it looks kind of close to what we just did. So we had 2x plus 4 equals 12. Now we have 2x plus 3y equals 12. So it's a similar problem. So we're going to take it to the next level, and now we still got some numbers, but we're going to add another letter. Now this we've done before. Okay, we did this. I even have the instructions in your notes for this. We're doing algebraic conversion. So we're converting from standard form into slope intercept form. So we've done this before. But a bunch of y'all didn't do well. Hopefully this will help you do better at it. Okay, so again, we're going to do that same process. It's all about thinking our way through. Now, eventually, you won't have to write your do and undo list. I do that in my head now. I don't have to write it down, but this is what I'm doing. This is what I'm doing when I solve a problem, is I'm thinking my way through this. Okay, so when I say convert into slope intercept form, do you have a question? When I say convert into slope intercept form, what I mean is solve for y. Okay, so there's a few ways that you might see this. You might see solve for y. You might see write an equation to represent g. You might see v equals pi r squared h for h. Something like that. But they're going to tell you what variable they want by itself. Okay? In this case, sorry, I got to use this one. Okay, settle down. Slow your roll. In this case, they're saying solve for y, so that means we want y by itself. So I'm going to highlight y or circle y, whatever makes you happy, but I need to make sure that I call attention to y because I don't want to forget that that's what I'm trying to isolate. Okay? All right. So what is the first thing, according to what our step we just last did, what do I have to do first? I got to write Gemma, right? And I'm doing that so that to help myself remember what I got to check for, okay? And then I'm going to write do and 1. Now, I don't know how many steps I'm going to have, so I'm going to write 1. I'm not going to write undo until I'm ready for it. But I know there's going to be at least one step, okay? So, do I see any grouping symbols? No, so I cross off the G. Do I see any exponents? No, so I cross off the E. Now, do I see anything multiplicative?
Yeah.
What do I see that's multiplicative? I see 2x and 3y, but what variable am I solving for? Y. So I only care about what's happening to the y. So what's multiplicative related to the y? 3. So what does that mean I did? I multiplied by 3. And I'm not going to write multiply. I'm just going to write mult because I'm lazy. I'm efficient. Okay, I'm ruthlessly efficient. I'm not writing extra stuff. I ain't got time for that. Okay, so now that I've dealt with that, I don't see any more. Now, again, I see this other multiplicative thing, but it's not happening to y, so I don't care about it. Do I see anything additive?
Yeah.
Anything being added to the y term? 2x, right? Didn't they add 2x to the y term? Yeah, so my second step would be add 2x. Okay? Is there anything left? I got the 3 and the 2x, I'm done. Okay, so now what do I have to do? I got to make my undo plan, okay? So I did them in this order, I'm going to undo them in the opposite order. So the first thing I got to do is deal with this adding 2x. How do I undo that? I subtract 2x, okay? Now I got to figure out how to undo multiplying by 3. How do I do that? I divide by 3. Now I have a plan for how to solve this problem. Okay? So let's do it. First step is to subtract 2x. So I'm going to subtract 2x from both sides. Now, I had somebody in one of my classes, I'm going to put a check mark next to that so I know I did it. I had somebody in one of my classes say, well, isn't that 10? No. Well, no. I can't subtract two things that aren't the same. That'd be like I have 12 children and I'm missing 2 buses. Does that mean I have 10 children?
Yeah.
No, it means I got 12 children and I'm missing 2 buses. I've got 12 minus 2x. I can't put those two things together. They're not the same thing, like, at all. Okay? But if it was 12x minus 2x, yeah, it'd be 10x. If it was 12 minus 2, it'd be 10. But they got to be the same thing to be able to subtract them. Okay? All right, so I've done that first step, subtract 2x. What's the next step?
Divide by 3.
Divide by 3. So I'm going to divide everything by 3. 3y divided by 3 is y. 12 divided by 3 is 4. Negative 2x divided by 3 is negative 2/3 x, because negative 2 divided by 3 is negative 2/3. Now, did anybody kind of want to do negative 2x plus 12? That's okay, that's not wrong. So if you said negative 2x plus 12, you would have divided by 3 and gotten negative 2/3 x plus 4. Those are equivalent. Okay? Honestly, I just did it like this because everybody's like, where are you doing it? And people have been freaking out all day. I'm just trying to make it look as easy as possible. Okay? But these are both equivalent. And then I'm done. Because I'm not finding, all I'm doing is kind of rearranging it. Now, this is in slope intercept form. I can graph it if I wanted to. I can find the slope is negative 2/3, the y-intercept is 4. All right? Now, we're not going to do anything this difficult today, but I needed you to see this so you could see what the steps are, because everything we're doing today is one step. On a scale of 1 to 5, how are we feeling?
5.
Wait, is 5 being good or 5?
5 being like, oh my God, I could do this in my sleep. Like, why are you even teaching me this, dum-dum? Okay, and 1 being, where am I? What's going on? And a 2, like a 3 means, I think I got it, I need to practice. I'm going to raise that up here in a minute, okay, because we're not doing anything this complicated. So let's go to this page here, and we're actually going to squiggle this problem out, because that's actually a 2-step problem, and I'm going to give you another one to try in a second here, okay? So let's look at this potential energy nonsense. Now, I'm just going to state for the record, I would never seek to disparage your science teachers, but I don't really care about potential energy. All I care about is this is math class. All I care about is what they're asking me to do. This says the formula for potential energy is P equals mgh, where P is potential energy, m is mass, g is gravity, and h is height. Write an equation to represent g. What is the only thing I care about? G. Right, that's all I care about is g. I want this to go from that into g. So I'm going to rewrite the equation. Why am I going to rewrite it? Well, I need to be able to do stuff with it, and that's too small, and it's all up in the middle of that problem. I'm not trying to, not about that life, okay? And then what do you think would be a good idea? I think I need to highlight the G or circle the G or something. Again, because I'm telling you, when I was solving this problem, I did it wrong 3 times because I did not highlight the S, and I lost track of what I was doing. Okay? And I had it solved for everything else but S because I lost track of where I was. Okay? So, I'm going to write Gemma. Now I'm going to write Gemma, and then I'm going to write do, and a 1, because I don't know how many steps I'm going to have, but I'm going to have at least 1. Okay, so what question should I ask first? Grouping symbols. So like parentheses, brackets. Do I have any grouping symbols? No. There's no parentheses or anything. Okay. Do I have any exponents? Anything raised to a power? No. What about multiplicative stuff? Yeah, right? So what am I multiplying G by? M and H. See, P's over here by itself. I don't care about P. I care about M and H, right? Now, Question. Do I have to do this in 2 steps, or could I just do it all in one? Like,
You could do it all.
do I have to say I divided by m, I multiplied by m, and I multiplied by, or could I just say I multiplied
And divided.
by mh? Boom, I multiplied it by mh. I don't need to get special and fancy, okay? I can do them both at the same time, because remember, I could rewrite this as mhg, and then the m and the h are right next to each other. When I multiply or add, the order doesn't matter. We're almost done. When I divide or subtract, order matters, but not when I multiply. Okay? All right. So how am I going to undo that?
Divide.
I'm going to divide by mh. Okay? So I divide by mh, and I do that on both sides. So what happens to these two m's? They cancel, right? They cancel out. And what about these two h's? They cancel out. Well, does anything cancel over here? Nope, because there's nothing the same on top and bottom. So I have P over mh equals g. And I'm done. That's it. It's all one step today. Are we anywhere closer to a 3? Let me give you one to try by yourselves, okay? Let me give you one to try by yourselves.
Can we try one off the homework?
I suppose so. Let's do V equals LWH, but I want you to write it in your notes. V equals LWH for W. That's LWH. So it's number 7. V equals LWH for W. L looks like a 1, so I do my L's fancy. Okay, take a minute and solve this one, and then we'll be.
That's an L?
That's an
Oh,
L.
I thought that was an E.
It's a cursive L. Good God, you guys. Because this is how I was taught. I was taught to write all my variables basically in cursive, italicized. Okay, y'all solve this problem. Okay, this is what you should have gotten. Hopefully this helps. We'll do more challenging problems on Monday.